Hello, everyone. Welcome back to a new episode of thenet.lol, where you're joined by myself and my co-hosts, Tom, Dave, and Brent. And we are very excited to welcome back to the show our first reoccurring guest, Mr. Vinny Parla.
Yay.
So, Vinny, welcome back.
Happy New Year, Vinny.
Guys, it's an honor to be your official first repeat. So thank you very much for inviting me.
I guess we didn't upset you enough that you wouldn't come back, right? So we're just happy you were willing to come back on the show.
Right.
It was a blast. I had a great time.
Right. You know, no one else has agreed to come back on, so I don't know.
Yeah, you're the first. I don't know what that says, but we're willing to go with it. We've got some interesting things to discuss for sure because you know, I'll put a link to this in the show notes, but Vinny, I remember at the end of last year, you wrote up a really nice analysis of everyone's what at the time what was the latest exploit, the log4j exploit, and I'll put a link to your analysis in the show notes so folks can go read that offline. But do you want to give us a summary of, first of all, remind us a bit about what log4j is, and then we can kind of dig into it a bit.
Sure. So log4j is an Apache open source library that's widely used as a logger. So it's a popular logger in Java, and many frameworks, even if you're not using that logger in your enterprise products directly, you may be using them indirectly through, you know, some other technology that uses it as the primary logging function. And a vulnerability was discovered in it, and what's interesting about that is that the vulnerability is really not in log4j. Log4j is just the easy button for an underlying vulnerability that's in Java. So the issue is really in the core of Java's libraries in something called JNDI. And JNDI is the Java Naming and Directory Interface Service. And, you know, everyone's you know, as I described in my blog, everyone sort of missed the forest for the trees, which is, you know, everyone's hyper-focused on log4j. Well, log4j is just one example of a possible attack vector. There could be 100 other libraries that have this same vulnerability that folks haven't realized at this point. Right? So while log4j made a really super easy button exploit for taking advantage of this, it's by no means the only exploit path, right? The other thing is that's interesting about log4j is this vulnerability was introduced in 2013. So, you know, how many years was this exploited?
Yeah.
By maybe a nation state and kept quiet, right? Because they're not going to go publish their backdoors, right? So how long was that exploited before it actually became public? And I honestly feel this was like a nation state toolkit, because when log4j became public, the vulnerability, all the exploits you saw coming out were like ways of doing Bitcoin mining, like exploiting and dropping your Bitcoin mining payload. Well, that's your sort of, I'll call it the script kiddie level attackers, right? You didn't see a lot in the news about people, you know, you heard stories like China's weaponizing this and Russia, you know, those generic sort of stories, but you didn't hear any specific story of someone getting into some large company's infrastructure and exfiltrating all their data, right? And
we know it happened. It's just nobody published that stuff because you know, that's not great news.
No, it isn't. But by now you would think some of that would have come out, right? In other words, SolarWinds, when that exploit happened, you know, most of the companies that were impacted were published. Now, there was a reason why. That's because in the SolarWinds attack, the actual encoded URLs that were published had embedded in them the companies that were attacked.
Yep.
So they were sort of public information about that. But still, this log4j exploit is big enough where you would think there would be something, if someone were breached by it, you think it would have come out by now. No, maybe it hasn't, right? Maybe it will.
Well, one question that might help people listening too is you're alluding to it's a bigger problem in Java, and this could come with the JVM that everybody has.
Yes.
Right? So can you describe that, the more general issue?
Yeah. So JNDI is a set of libraries, and I have a link to a picture in my write-up on it. But basically, it's a set of libraries that let you do various lookups. So, for example, LDAP. So if you want to look up a username, you're doing an authentication, and you want to look up a username doing an LDAP query, you would use this library, JNDI. You pass it the right values for the username and whatever, and it would do a lookup in the LDAP service to validate that, okay, Vinny's an authorized user, right? But there's many other lookup engines. There's a DNS lookup engine, there's an HTTP lookup engine, a Corba lookup engine. So all of these sort of common protocols that you might do a lookup with are available in the JNDI library. So it's an interface basically to make it easy for developers to do various types of lookups. Now the problem with this library is one of the resources it can return is not just a username or parameters about a user. So if you did an LDAP lookup, it would return, Vinny, he's works for Cisco and he's part of, the engineering organization, your typical Active Directory LDAP type record, right?
Yep.
But the other thing it can return is a reference to code or the actual Java code itself. So one of the things it can return are objects, right? That's horrible.
That's
that means
exciting.
Basically, you have a framework that can return to you unvalidated code, right? So if you have a way, and this is the problem, and then I'll explain it really quick in log4j. If you have a way to tell it what LDAP server to use or what DNS server to use, right? Now you have an exploit vector where you can basically say, go to my LDAP server and download this malicious code. Well, that's precisely what log4j exposes. So log4j added this ability to do something called lookups, right? And what lookups are is when you do logging, you can pass it these wildcard parameters, and on the fly, it'll go look up those parameters and substitute them. So you can see how that would be useful, right? If I want to put in my logging what organization Vinny was part of. So I'm logging, Vinny failed doing an authentication, but I want to put what organization he's part of in the logs so that later I can say, oh, the engineering org should have had access or something like that. So you would pass to log4j a parameter to have it look up the LDAP record, and you'd parse out of the LDAP record what organization Vinny belonged to, and you'd log it, right? And log4j gave you a nice little lookup mechanism that would substitute special curly brace values for the looked up values. Well, the problem with that is I could craft a logging message, right, that basically said, use Vinny's LDAP server and look up this value, and the value to look up was actual Java code, right? So that means any field that you could get the logger to log, so take a username, right? A failed authentication, what's likely to happen? You're gonna log the username field from the web form, right? So in that web form, if I can put the right sequence of characters, curly braces, LDAP colon, it's just a URI, LDAP colon // and a bunch of parameters pointing to my LDAP server, what happens is the logger goes and does a lookup. So it calls out to my server, right? And my server returns the serialized Java object that it now actually loads and runs. So
without asking any other questions.
So basically what you can do is wire up a circuit just by passing the right parameters. You can get the Java code to wire up a circuit that reaches out to your LDAP server, grabs a piece of Java code, downloads it, and then inside your internal application runs that Java code.
Yeah.
So that basically means you can do anything that you want, right? And so
Yeah,
if I'm a
besides
clever,
executing the code, I mean, you're talking about the LDAP database. I mean, you could suck the whole LDAP database down and then offer it up. Your whole DNS internal mapping, offer that up. I mean, these are the things you can do with this kind of problem, you know.
yeah.
You could
Well,
hook circuits
and
up,
the
like you're
biggest thing
saying,
is,
all of these
it,
internal services and then vacuum them out.
yeah, and that's one of the so that's one of the vulnerabilities is you can um, take all of the environment variables off of a server and extract them. Well, what is one of the popular things in cloud native to do? It's to stick your AWS keys in environment variables,
Yep.
right? Or your AWS credentials, right? So if you go look, if you run the AWS CLI, right? And this is true, I'm sure, of Azure, and I haven't used Azure a lot, but I'm sure it's true of any of these solutions, right? So I'm not picking
Yep.
on AWS, but basically, it's not uncommon to put credentials and keys in environment variables. It's a bad practice, but it's done, right?
Yep.
And
Yeah.
so you have your service basically is set up where you can now exfiltrate all of these environment variables. And now I have your AWS root credentials, and I go on and sign on. And from there, I get anything that you could get in
And have
AWS.
more fun.
It's
Yep.
it's much bigger than just the server you're targeting. It really opens the door to anything that's on that server.
Right.
So if I've exploited this server, and this server has a connector to a database, well, I can exfil everything on that database, or I can get your AWS credentials, or I can, and then
Or
pivot
you
to your
get
AWS.
credentials. A lot of people put those keys too in their environment variables, and
Yeah.
that,
Well, it's like everything, right? The whole idea behind 12-factor apps was environment as configuration, because then we can deploy them anywhere and just change the config on the fly. And if those are all susceptible, then yeah, that's a big problem. But what gets me about this one, right, is that it's beautifully crafted because no amount of supply chain security is going to protect you from this. You could build your app as nicely as you want, but you can verify all of your dependencies are from the right places, but you don't really have any protection, I think, from this.
Yeah,
well, if
you
the
basically have,
system is intrinsically flawed, then all
Right.
bets are off. That's the problem, right? I guess there's this weak assumption that it clearly is weak now, right? That this trust in the JVM and Java and the whole accoutrement around that it's secure and well set up, and maybe that, demands more security analysis, before going live with these things and tripping over ourselves to make the next release come out in the next 3 hours kind of thing.
Yeah, but this is a platform problem, right? And I think that's what irks me about this. Vinny, after you explained that this is a JNDI bug, like this has been painted as log4j. Those guys did something wrong, but
It's a platform bug, yeah.
right, this is a
Absolutely.
platform bug. And any platform that offers like remote code execution of download this random thing off the
But
internet.
that's why I
and run
asked
it,
Vinny, like,
is
explain the root cause of this thing, because it actually impacts anything that uses that library.
yes, and the thing that's interesting about this is in 2016 there was a black hat presentation on this exact vulnerability, and what did everyone do? They yawned. Oh, Java's got this huge security hole in it. Whatever. Next.
Yeah, exactly.
Right. And
Yep.
people have already
Well,
forgotten about log4j, right? It's like already out of our, collective memory. It's like on to the next issue, right?
And it's
And
kind
well,
of a
and that's the thing,
question.
right? If you're relying on the teams that are building code to do this, I mean, or to fix these issues or address them or even preemptively look at them, they're being driven by product management on the one side to deliver features. And I mean, Vinny, you and I know this. How often is security built into these things? Well, we got to deliver this or we have to fix these security vulnerabilities. Which one do you do?
right,
You know,
right. It's all about feature velocity.
feature
Security
velocity.
vulnerabilities don't create new features that create new revenue.
Well,
100%.
there's always the assumption that the platform is secure, right? And I think that's the issue here, because we move the platform around on a regular basis, right? Oh, 1 week it's OpenStack, now it's Docker, then it's the JVM running in Docker. Like, whatever it is, we're building applications, we're not building platforms. So the value is always going to be in the app, and the platform is going to be the bit that gets the less attention, unfortunately.
So it's kind of, this begs the question. Sorry, go ahead, Danielle.
I was just going to say, unfortunately, the people building the applications don't really understand how the platforms work.
Right.
Yeah.
It's like magic mystery sauce, right? It's that magic smoke inside of electronics, right? You don't really understand the internals of how it works.
No, it's
that's how you end up letting the smoke out.
Right. And so you're just using these frameworks, and and it's obvious from this log4j exploit that most of the people don't understand what's going on, because they're all focused on patching the log4j library. Right. They're not sitting there going, where else could JNDI be exposed besides log4j? Like, that's the security analysis that should be going on. Yes, you need to deal with log4j, but where else is this kind of functionality exposed, and what other libraries am I using that use JNDI that, maybe it's not an easy button like log4j, but maybe if you craft the right sequence of input, you can get this other library to do something. Right?
I mean, this is kind of begs the question that, like, I don't want to sound like, that old guy on the lawn who takes everybody's ball and bitches about stuff, but, like, I've been bitching about this since I started teaching computer science graduate classes in 2000, where I had students that didn't know what they were importing. And this has just gotten monumentally worse. Like you said, Vinny, problem solved, easy button. I imported this library. It claims to do a binary search and returns me what I need. What it's doing in the meantime, I don't know.
Well, and it gets worse from what Dave was saying too, because you take what you're saying, the developers importing these random things on the internet, and now look at the platform stack that we've given to these people, right? So it runs in the JVM, inside of a container, orchestrated by Kubernetes, inside of a VM, on a host, with actual physical networking equipment. Do you think the app developers could tell how their packet gets from the network into their application running on the JVM? I mean, it's very complicated, and we've done this to ourselves, I think, at this point.
Right. But the difference is, right, an enterprise now will pay a cloud provider the money so that they don't have to care about, I care up to the container level, but the runtime and the platform is your problem.
But that's exactly it.
Model.
The problem, if you're shipping a commercial derived version of any of these things, it's your responsibility. You are paying, people are paying you to build this thing, right? I mean, I've had these kinds of debates and discussions, not only my current employer, but previous too, about, open source. This is part of the non-free lunch of open source. If you're building platforms, you got to know what you're building it with, right? I mean, and that's, there are companies that I know of that don't have teams that know anything about any security, anything. They're just like, yeah, I'm going to build this derivative of whatever, Kubernetes or something, and off we go.
Don't we think the hyperscaler takes a piece of the problem away from you, but take the log4j exploit. If I'm running a container in AWS or Azure or GCP or whatever, and that container application is vulnerable to log4j, well, then I can get to everything that container could have gotten to.
Right.
And it's likely it's going to connect to a service over a service mesh without a credential, right? Meaning without an explicit JOT token or bearer token or whatever. Yep. And so as an attacker, I'm going to do the exact same thing. I'm going to try all of your local ports for a service mesh and see what else I can connect to move laterally. And then maybe that next thing I move to is really much more powerful than the container that I'm in, right? So now maybe I move to some multi-tenant component you have on the other side of that service mesh, and now I have the keys to every customer in your ecosystem, right?
Well,
Well,
that's the flip side to the mass automation of everything. I mean, once you have the 6 or 12 keys you need, you get
yeah,
access to everything that's automated, for
yeah,
example, right?
yeah, yeah, yeah.
Well, I don't want to lose Dave's point though too, because Dave's point
Sorry, go ahead.
was good.
Yeah,
Was around this whole platform
The
thing, right? And
platform is,
running on the hyperscalers. I think it's true to acknowledge that. I mean, who can run the platforms better, the hyperscalers or all of these enterprises individually, right? And
It, it
I think Dave's point
it's when
is
you don't
accurate.
realize, Kyle, that Java is also a platform. Right? You're
Yeah,
paying somebody to look after the container
there
below,
are
and
people that
that's,
sell commercial JVMs and, and
that's right.
development
That's right.
environments run JVM, yeah.
right.
right.
So that's the type of thing, right? You can push the problem away, but unless you completely understand your technology stack, you can pay up to a point so you don't need to care about it, but there's still that debt there, and
That's
that's
the point
kind of
I'm
Vinny's
making
point,
and
right?
agreeing with Dave. Absolutely. I mean, like, wait a minute. Who am I buying the software from, and why aren't they going through it with a fine-tooth comb, you know? Um,
Right. But in a lot of cases, like log4j, you're not buying anything. It's open source, right? And so now
exactly.
you're relying on a library.
Well, no, you're buying, like if you buy AWS service or Azure or whoever, right? You're
Yeah.
still buying that service, but you're buying it from them. Or if you buy OpenStack or OpenShift from Red Hat or whoever, still buying a curated package that
Yes.
that has a license. You know, they're offering a license and a guarantee of some sort that the thing works to some degree, right? I guess maybe that's the question consumers should be asking now is like, what's the deal with your security, warranty or guarantee or your platform, right? Because that's kind of
Yeah.
where we're going, right? There's this implicit assumption that you buy, like when you buy a car from a car company, you assume that the locks work on the doors, right? Generally speaking, that people just can't walk in and hop in and drive away, right?
Well, I mean, unless it's a Tesla, then you don't make that assumption.
Yeah, then
Otherwise,
it's
yes.
Bluetooth, right? Fun. Or the
Well,
doors don't open.
but they still break your window and steal the stuff in your car, right? So I mean,
But
That's
you
right.
get the point. I mean, it's still like,
yes,
it's like,
yeah,
come on, there's a commercial
there's an
relationship
expectation.
here.
And maybe you start, with SLAs and SLOs, maybe security gets, it's always about uptime, but maybe there starts to be a demand for security guarantees, right?
It really
Like,
is. I mean,
you
it's
know,
kind of like we've been lazy and gotten away with it, right?
right.
We have, and we've also, like, with open source, allowed that to happen because, like Tom mentioned, there are commercial companies that will sell you a commercially supported JVM, but they weren't the ones spending their holidays fixing bugs in
Hmm.
log4j. They all got their paid time off, and it was the open source maintainers that caught the brunt of it, sadly.
Right. Which gets into the other, like the NPM thing that's been going on. Um,
I
that
also
that
think there's a incorrect expectation that developers have security expertise. Very few people in the industry have
well,
actual
look at
security expertise.
look at all the
Right.
Linux Foundation projects that are out there today, for example, right? We all have all worked on these things. You go to Linux Foundation network area, there's like whatever, 8, 9 projects there. There's not a single group dedicated to analyzing and continuing to analyze and monitor the security situation of those projects. And worse, some of them are amalgamations of many projects. So it's like many layers of kind of the example you gave earlier where like the enterprise thing, like, well, I buy this and I buy that, and I go, no, no, no. I jammed it all
Now
together.
do Go. Now do Golang, right? You
Yep.
suck in like
Yeah.
30 dependencies from unknown repos that there's, you know, I've seen repos that are in production code that there's one person maintaining that library,
Yep.
and they're just some random dude on the internet, so to speak, or dudette on
Remember
the
the
internet.
SSL
Right?
library issue we had a couple years ago? There was, what, 3 people working on this like for free. And
Yeah.
Yeah.
the thing that people don't realize, and then this curses, terminal thing is another one, and there's all of these intrinsic nuggets underneath here that get combined together to build this, that they're the foundation. And who's like looking at the foundation going, is it made out of sand? I don't know.
I mean,
It,
so on the flip side of yeah, it might be just one person, random person on the internet maintaining this project. The good thing is it's easily traceable to go look at that code, right? So I can go look at that repo and I
It's the
can see
go
an
look at the code though. That's the lazy thing that's happening. People
yeah,
aren't
yeah.
doing
I
it.
mean, yeah, but
That's what I mean.
people haven't been looking at source code forever, right? I mean, at least there's source code to look at. Where 20 years ago there wasn't
Well,
source code to look
right.
at. It was
that's
somebody's
fair,
binary that changed things off.
but how many people understand the implications of an integer overflow in terms
Right.
of a security vulnerability?
See,
Very few
that's really
people.
where it hits it, right? Because for a long time, and I've been in these, you go to conferences and people talk about this and go, well, open source code is inherently more secure because you can see it. Well, if a tree falls in the woods and no one hears it, so what, right? It's the same thing. If no one looks at the code and analyzes it, right?
Or doesn't have the expertise, right? You can have someone
Or
look at the
doesn't
code
know, but yeah, yeah.
and they don't see, and they see that you have an integer type and you're passing something that should have been passed for should have been a long or something like that, right?
Yep.
But you're using an integer type and you have an integer overflow. 90% of the people out there would have no clue what vulnerabilities are actually exposed by that integer overflow because they've never been trained in it.
Or
Right?
they
Like
just I was just looking at some code. My kid works on DPDK right now, and there are uncaught exceptions when you run the thing. You're just looking at this and going, who's checking that out? That could be the next log4j in here, And it's just lots of
It would have to be
exceptions. They're
widely deployed for
informational.
that.
Let's move on, skip it, keep going.
Well, there's kind of this missing year of CS education, right, about the real world and understanding where dependencies come from and what they do. And I think what's been really good is that a lot of the languages have increased in the ability to do good static analysis and things like fuzz testing and other things. That's kind of cheap and free and a good at least smell test that you can take a look at a library and be like, does this have at least more than one contributor? Like, does it do static analysis? Has it been fuzz tested? Like, all of these things can be done, but nobody does them because, it's hard work because it's not just a dependency; it's the dependency of the dependency.
But that's why it gets done. It's forced on them in language, and it's intrinsic. It must happen. Like you can't randomly cast types to other types without, or things like that. But that's just part of it, right? We're talking about like also massive distributed system complication here too.
There is.
When we talk real world as well, though, the real world is also, ops teams that are totally underwater can barely deliver what they're supposed to deliver. Their number one measurement, like Vinny said, is uptime, and to expect everybody to be security experts. I think
uptime and minimal people working on it. That's the
right,
thing that's
right.
always given me like a little twitch about, 100% automation sounds great, but what it does is it leads, I've seen this now, and we're talking about this, the frog slowly boiling in the water. Over time you go, wow, it's all automated. I could put my feet up. It's all great. In fact, we need fewer people to work on this. Instead of 6, well, let's try with 3 this year. And, instead of taking those 3 people and saying, you guys go ahead and make sure this thing is buttoned up secure-wise, or hire other people or whatever, you know what I mean? Like Vinny's point about maybe they just don't know how to do it. But like,
security is always overhead, right? Like security is always overhead. There's no ROI on security unless you start gaming out what ifs. It's always a what if.
That's the
what
thing.
If this happens, we're going to lose $10 million. If this
there's
happens,
negative ROI for not doing it. That's the thing.
yeah. I mean, so the dollars ebb and flow. Like Vinny, I guess what are the baby steps that are like super easy? That are what can people do to start doing some of the basic, is it fuzzing? Is it like, how do we get proactive about this rather than reactive? Once every 6 months, we all freak out and patch machines, and then, everybody forgets about it when it doesn't happen for another 6 months.
So I think the first thing I would suggest is that every new hire be required to take a secure coding class in the languages they're going to code in, right? And a really good secure coding class that goes and actually explains like what types of things lead to vulnerabilities, right? Because as a coder, if you don't understand how passing arbitrary parameters, which is what log4j essentially is doing, you're passing it arbitrary parameters that it's resolving into code. Had those log4j developers been properly, trained in the security aspects of that, they might have thought twice about introducing that code, saying, well, I'm allowing substitution parameters here, so what could someone potentially pass in that could be substituted, right?
Or the dangers of sending around, generic strings, basically,
right.
JSON payloads or whatever. That's not the problem. It's the when you get it and doing something with it, making the decision to do something with it, and that's what you're saying.
And I think just very fundamental vulnerabilities, integer overflows. I don't know if you guys were familiar with the Python exploit that was out there for years with the double printing of a double and the fact that you could, have the precision result in an overflow, because if you set the precision high enough in the logging that you could actually overflow in the printf function. It's those type of things that if you just got basic training in those type of rudimentary exploits, you'd start thinking a little bit more critically about, hey, I'm taking input that's unvalidated. What constraints should I put around these inputs before I do things like log or pass it to some other function or put it in a database? Yeah. So I think training would be the first thing, required training for every new employee. And then the other thing is, you always hear about a site reliability engineer. You never hear about a site security engineer. I've never heard of a role like that. Now, maybe there are companies that have that. I'm sure, hyperscalers probably have tons of those kinds of roles. But in general, you needed someone paired up with the SRE that's a real security person, real security expert, and knows kind of the things to look for, and spends their time as the site reliability engineer is building all of the sort of fault tolerance and reliability into the infrastructure. That security engineer is going in and building all of the right security and ecosystems to strengthen, your systems so that if you are compromised, you can't move laterally, or if you do end up with a log4j, that it's isolated to just that container that you can maybe exploit, and you can't pivot out of that container into another system, right? And that's something that a good security engineer would be able to say, oh yeah, you need to have bearer tokens for all your communications, or you need to use MTLS or whatever, and rotate your certificates. Like, there are ways of doing these kind of communication protocols where you authenticate, machine to machine, as opposed to today it's largely not authenticated, right?
But there are
service meshes that do authentication, but your communication with the service mesh is not authenticated, right?
But isn't that part of what the challenge is today? There's always like the security person. If you're lucky, right, you'll have and that person is typically regarded as the person who says no all the time. People avoid that person. You know what I mean? Like, this is the one person that could stop a release. You know what I mean? And I've thought about this too. And I mean, maybe the flip side is kind of what you said, is making it everybody's responsibility. Everybody that contributes code to this product has to take the training, has to be on the lookout for these things, maybe one idea I had for our next hackathon is, let's try to break our own products, and then just get that on people's minds.
And it goes beyond just making all the engineers do this. I think product management needs to get involved in security as well, because otherwise it's like you said, Tom, the security person just becomes a blocker, right? Product management is gung ho about features and we need this and customers and blah, blah, blah. But
Well, and over
they
time
should
they
also
become
be
such a
pushing
pain in the
security.
ass. Nobody talks to them
That's right.
anymore.
Yeah,
Right.
and I think it's the whole org has to kind of buy into it. But I do think that a lot of these orgs do what you're saying, where they say, well, I have my security person, so I feel good. I've checked the box. There's the security person. I can rest easy. But it's just never the case. In fact, it's almost the opposite.
It's the
It's such a
opposite.
weird
One
role to
person.
hire for.
Yeah.
Like,
How's that
in
one
my
person gonna go
experience,
through all your products? You know?
yeah. Well,
And
a lot of security people that I've met have, like, they deal with all aspects. But, like, software is just like this one thing. And it's like, I can do all of your data center access control, and I can tell you what all of your
Yeah.
procedures should be. And,
Yep.
like, software security is this very slim thing. So I think definitely that role that Vinny's talking about, somebody, a software engineer or somebody with a software engineering background with an interest in security and domain expertise in security to work alongside, an SRE and that type of team is.
But that's what I'm saying is like that person needs to actively spread the knowledge and responsibility to make it, everybody's problem. I mean, I worked at several places and recently in the last, 10 years, say, and there's somewhere between 1 and 5 people in a company whose responsibility is what we're talking about. And these places had tens of thousands of people working there. I mean, proportionally, it just seems off. Given the scale, I mean, like you said, the software thing is just one of these many security areas, but like the other ones, it's deep, So
I
it's not
think to
something
Kyle's
that's
point,
like-
though,
Yeah,
on the product management side, like Kyle, I strongly agree. Like, tech debt is one of those other things which also goes unnoticed, and
Yep.
that's where the big security risk is as well. All of these things that I wish that I could have done should I had the time, and probably should have done, but forgot to because we had to rush the feature.
And getting product management involved, so it's not so tech debt and security and these types of things aren't a burden. They're part of the roadmap from
Part of the
product
thing.
on down,
Yeah.
and it becomes a discussion where, okay, we're not just talking features, we're talking about tech debt and we're talking about security and how we're going to, factor that in. So
make
yeah,
software security a feature that
make
the product manager puts on the roadmap.
rewrite it all in Rust so we get memory and type safety and lack of undefined behavior. It'll all be fine.
Hold on. Yeah. No.
I also think you need your distinguished engineers and fellows at companies to be your security evangelists, right? There's not
important.
enough people at that level pushing, they have a lot of influence in those companies, CTOs as well, right? CTOs in the different orgs.
Oh yeah.
They have a lot of influence, and if they sort of put their thumb on that, we need to do better in the security area, it'll happen over time, right?
Well, you know what it is? It's that folks have gotten used to just being lazy. I mean, I was talking to my son who's in the computer science program right now, and like low level stuff is not sexy and cool these days. Like learning assembly language and learning, so like some of these, integer overflow issues, if you don't understand what's going on downstairs, you've only got part of the story. And security from my interactions has typically been part of that. It's not the sexy stuff. It's always some weird, obscure, dark corner thing, conversation. You know what I mean? And so you're right, Vinny. Making it a thing, making it important, making it. I don't know if it'll be cool or not, but just making it a front and center important thing. Software security, in case we're talking.
And Tom,
about
I think you just stumbled into perhaps the next show when we have Vinny on in the future. We should talk about firmware security and some of these low-level security things, because that's completely forgotten. We didn't touch on it, and the amount of trust that we put into many of these vendors
things,
with exactly all of these types of things. So that might be an interesting discussion in the future too.
It's funny you held up your iPhone, right? Go look at the attack that was done that bypassed all of iPhone's security one of the best platforms in terms of security, and still attackers were able to bypass all of those very advanced security mechanisms using code reuse attacks, right?
Yep.
So, these things are going to, the attacker is always going to be more sophisticated than the practitioner. And we have to think that way and go, look, no matter what we're building, we're building features and solutions, and attackers are looking for the weaknesses, and we're always going to have those weaknesses. And, we just have to do our best to mitigate them and improve over time. But we also have to step back, and I think log4j is a great lesson, which is, what's the real vulnerability here? It's not log4j. Log4j was just the easy button, and people need to pay attention to JNDI and look at other places where that vulnerability is, because it's going to show up in some LDAP library.
Some other weird places.
Right? Everyone's using this LDAP library to do lookups, and it turns out if you give it these 3 parameters, it'll do the exact same exploit, right?
Yeah.
And that's the thing that bothers me. The other thing that bothers me, I want to just touch on real quick, I know we're running out of time here, is judge your security products by whether they could protect themselves from log4j. Look at how many security vendors scrambled to patch their own products from log4j, which tells you, wait a second, if they couldn't protect their own products from this exploit, how are they protecting my company from any exploits? Their own product was vulnerable and exploitable, right? And so that should be like an alarm that, look, you're spending all this money on security products that themselves are vulnerable to these exact exploits, these 0-day exploits that they should be protecting you from, and they're not. Right? And so as an industry, we need to do a better job in the security industry of actually building secure products, right, that protect themselves, that those products themselves can't be, compromised. And, until there's a shift, this whole shift left type of thing to start doing before the bomb goes off, right, before that exploit happens, until our products start doing that, this problem is just going to be,
it's going to
repeated and repeated endlessly.
Yeah. Well, Vinny, that was certainly a great way to kind of end things, and we definitely appreciate having you on again. This is, as always, a really great discussion. You got a lot of great insight for us as well. So we appreciate you coming back, and hopefully, maybe we can do that firmware discussion in the future.
Thanks for being on,
or something.
I love it. Thanks, guys. I appreciate the time, and as always, have a great new year. And
we'll
talk to you
definitely.
soon.
This was great, and thanks to all of our listeners as well. And Tom, did you want to take us away?
Yeah, thanks to our fantastic sponsors, T1 Nexus again.
Thank you for that, for sure.
Helping us out here, making this go.
Excellent. And thanks a lot, everybody, and we'll see you on the next episode.